Earlier, we talked about index addressing. So here, let's talk about more about index scaling. From before, you can see if we want to have an indirect or index operand, we always need to add the corresponding size of the value to the offset. So that's why you can scale an indirect or indexes operand to the offset of an array element. So by doing that, actually is done by multiplying the index by the array type. So here you will know array type basically mean each value, each element, what is the size in the memory. So that's why we see, for example, here, we have 3 different arrays. So the first one is byte array, then we have word array, then dword array. Each element, even you see the value look the same, but each one, for the first array, they're holding the value in 1 byte, then 2 bytes, then 4 bytes in different array. So on the other hand, if we want to save, for example, we want to save the number 4 to a location. So then here is, in order to save that value into another address, according to the data value where they store. For the byte 4, we need to save in AL. So word 4, we need to save in any 2 byte registers. For example, here we do the BX. So then for this number 4, that will be double word. So that will be 4 bytes. So then we have EDX for that. So then when you do that, your destination operand value, destination operand size need to be the same as your data label size. But here, even you have your array name, your data label, we have the ESI, we just have 4. That means we want to refer to the 4th element. But we cannot just using the 4. So instead, we need to use this ESI, then multiply by the type of the data label. So on the other hand, you can see here we start from array B, array W, array D, but how many bytes we need to move from there, they will according to the type of the array times your your number of the index. So that we see here, even they all look the same as number 4, but how to save the value and also how to access the correct location will be according to your index value and times the type of the array. So that's the index scaling. In this video, we want to talk about from what we introduced earlier in these 2 weeks. We talk about data transfer instruction, for example, move, add, sub, increment, decrement, or exchange. Then we talk about the data-related operator to associate with the array. Then we talk about the jump and the loop. For all those things we talk about in the 32-bit environment, what's different between the 64-bit programming? So the first thing, let's talk about when we do the move instruction. So when we do the move instruction, remember, right, we need to make sure our 2 operands with the same size. But also, if the move, the source operand is an immediate value, they will according to your destination operand size to copy over the value. So the same thing, move instruction in the 64-bit environment will be the same. They will accept operand of 1 byte, 2 byte, 4 byte, or 8 byte value. So here you see you have the move, but your destination is the RAX. So that will be 8 byte. So if you can, of course, that would be nice. You have all those 8 byte value to specify. So then they just copy over that value to the RAX. But sometimes you see you may not be able to specify all that the immediate value in the 8 byte, but you still can move the 1 byte, 2 byte, or 4 byte constant value. Okay, because you need to know constant value, actually, we don't really have the memory yet. So then, for example, you see you move the destination operand still RAX, But here we have 1, 2, 3, 4 bytes. So even here, I only give you 4 bytes. But when you copy over this value to the 8 byte location, so they will keep this 4 byte, of course, the same. So the rest of that, because we didn't know how much, or we don't consider the sign. So that's why actually they just fill out the rest of that as your 0. So any space they don't know to copy over to the 8 byte, they just have the rest of that is 0. They clear out all the bits for the on the left hand side for the digit. So the same thing you see here, I only have 1 byte, 2 byte. But when I move to the RAX, we have the last 2 bytes actually is 6666. But the rest of that, they will clear up. So then you will see the same thing for the 1 byte value. So this one actually will be the same as the 32-bit environment. So if you have a constant number, even you didn't give them the enough size for that, but a constant number is different. So when they really copy over to the destination operand, they will fill up with the 0. So then the other thing is, if you want to move a memory operand into the register, so then you need to be careful is you do need to have to match your data size. So for example, here I have my byte is 1 byte. My word is 2 byte memory operand. So then my word actually only can move to the 2 byte register. Then my byte for 1 byte only can move to AL for 1 byte. So then actually consider for RAX, they won't change anything. They only can access this 2 byte, the lower 2 byte. But this one actually is for the 1 byte and 2 byte when you do the move. They won't affect the high bits in the destination. But this one we need to pay attention. If you have a 32-bit memory operand, you want to move to the 8 byte register or location, actually they will clear up the high bits in the destination. For example, I have a D word. Okay, so my RAX, let's fill out with 00. But when you move your my D word to the RAX, they are not only occupy the lower 4 byte, the higher 4 byte actually they clear that up. So that's one thing is different from the 32-bit environment about the move instruction. So we talk about the move instruction. You need to be careful when you have your 32-bit operand move to the 8 byte operand. So then continue actually 64 bits, we still have the sign extension and the 0 extension. So then here you can see one thing is they will work the same. So that's the instruction you will see we have for the syntax for the move ZX. Earlier we only talked about 16-bit, 32-bit, but also they can work on the 64-bit for the 0 extension. So this one, remember, you can move a smaller size to a bigger size operand. So the upper bit, they just clear up. But that's move ZX. If we use the move XX, so the same thing, we still can work on the 64-bit destination operand. But one thing is, when they extend the higher bit, actually they were using the sign bit to extend. So for example, you have EBX is only 4 byte. So you want to move XX. So that this 4 byte you need to move to the RAX. So this one actually, because you have your sign bit is 1. So that's why here 1, 2, 3, 4. Yeah, so the first 4 bytes, they all be extended by the 1. So that's move XX and the move ZX. So that's about the move instruction. So the other thing I want to remind you in the 64-bit program is when you have your memory address you want to save. So that's we're using the offset operator, right? So since you are in the 64-bit environment, all the memory address actually will be the 64-bit. So on the other hand, you need to have 8 bytes registered to save the value if you want to save the memory location. So for example, even here is my array is the word. But when I want to save this location, memory location using the offset to save in RSI, so then here, right, RSI is 8 byte. Because one thing is, all the memory address when you are in the 64-bit environment, they will be 64-bit. In the other word, that will be 8 byte. So this one is the memory address you need to remember. And also the other thing about your loop instruction, the same thing. The loop in 32-bit environment, we use the ECX. We use the ECX as the counter. So then in the 64-bit, there will be RCX. So the same thing when you want to work on the array. Before in 32-bit environment, we're using the ESI and EDI. So then in 64-bit environment, there will be RSI and RDI for the most common 64-bit index register to access the array. So continue, we also can think about add, stop, and increment, decrement instruction. So those instructions, of course, they all affect the flag the same way as the 32-bit environment. So for example, here, if you have your RAX is the 4F at the end. So then you have BX, right, equal to 1. You try to add by 1. So you add AX with the BX 1. But here, like earlier we say, when you do the addition, right, since now you only have 2 bytes to work on. So that's why here, when they only add this 2 bytes. So plus 1, you see, they will all become 0, right? But remember, when they're all 0, actually, they won't really update the from those bits they shouldn't touch. So you will see afterward, this instruction, your RAX will be like this. And also here, to talk about is, after this instruction, your 0 flag, of course, because they are 0, you will be set. So then carry flag, because when you add, they are overflow. So carry flag will be set. So that's why how they affect your sign, your status flag, they will be the same. And also the same thing, if you want to do the scale, indexes operand, they will work as the same as the 32-bit environment. So you have the quarter word, so that's each element is 8 bytes. So I want to access number, here actually is number 4, because we do the RSI subscript is 3. So that's why this one is 0, 1, 2, 3. So 3 actually is the 4. So when you want to access the 4, you're just using the index addressing. So that's the array name. Then you have your RSI, so the subscript, so then times 8. Or you can say times type array. So then we can access the 4 and save in RAX. So the same thing when we talk about memory address is 8 bytes. So in 64-bit environment, a pointer variable also that will be holding an address, right? So there will be 64-bit 8 byte as well. So then you will see here when you have array defined like this, so then we want to save that the beginning of array into a location. So that's why here even the data type for the array is byte. So when we want to save the array B location, we need to declare and quote the quarter word. So then your array B value will be assigned to the PTR-B. So you can either write this way or you can write this way using the offset. So actually these two, they are the same. Okay, so actually the only left in this PowerPoint file is the 64-bit version of the sum array. So this one actually I won't talk about that line by line. So here I just want you to make sure you will pause the video and read this PowerPoint slides. Then compare it to what your array sum you have in 32-bit environment. Also how they are different, how they are the same. So that's your 64-bit environment to do the data transfer.